Hey, what's going on, guys? GoMagicGames here. In this video we're going to be masking rook attacks, and this is just like it was within the bishops in the previous video, so let me quickly walk through the visual example of what in particular was supposed to be implemented in this video, and then we'll jump into the implementation itself. So let's consider that we have a rook on d4, and now I want to be using the black pawns to show the bits I mean, from the bitboard perspective this is the bits, and from the chessboard perspective these are the squares attacked by this rook. And please know that just like we had this in case of bishops, we don't really need to mask the board edge square or bit in the case of bitboards, because it doesn't really affect the occupancy in terms like it will affect if say some piece would be occupying the this rook attack ray. So in case if piece stands on if piece stands on the board edge, the matter of calculating of generating the moves or attacks for a rook would be just like how we do with the lipper pieces. And what we really do care about, assuming the Magic Bitboard implementations, Magic Bitboard attack generation for slide-on pieces, are only these bits. So what we really care about is whether the occupying piece stands here or here, respectively, or if it stands here. So this is the only thing that will matter regarding every single direction here. But again, in this video we'll limit only to generating this to masking the rook attacks, and that's kind of it. So without further ado, let me just go to the code, and please don't get confused by the amount of code, because it already has some stuff for pre-calculated attack tables for pawns, knight, kings, and also the bishop mask is also available here from the previous video. And I'm just skipping the code altogether for those of you who kind of is more experienced in chess programming. This would probably make more sense just to have all the stuff in one file to make use of. But again, like, this is obviously the standalone tutorial, so we're not going to be relying on the code that is already written, apart from using this print bitboard function that would be able that would give us an opportunity to print the unsigned one-long integer, also known as bitboard, in a binary representation and in a printed format of A to A table, where zeros representing the bits that are off and ones represented the bits that are turned on, basically. So it's quite pretty clear. Also, we have this square mapping and the definition of unsigned long type. We don't even need the bit manipulations in this video. So without further ado, let me actually start implementing our mask rook attacks function here. So mask rook attacks, and here I'm creating the U64, which stands for unsigned long type function called mask rook attacks. And it, just like in case of bishops, it would be taking the square as its argument, and we need to create the attack bitboard, just like we've been doing all of the time. So this bitboard is the one that we're supposed to be returning back after this function actually works. Okay, so attacks equals 0 unsigned long, and also we want to do this stuff. So return attack maps, return attacks map here, and exactly the same, just like what we did with the bishops, we need to initialize files and ranks. So int file and rank. And for those of you who didn't follow the previous who didn't watch the previous video, I need to say that this implementation is based on Tord Romstad's implementation. So Tord Romstad is the guy who is one of the guys who has created Stockfish, so very famous chess engine developer. and this is his elegant approach for generating rook attacks. So I didn't invent this on my own for sure. And also we need to initialize target score files and ranks. And how exactly this target files and ranks works is available in the previous video regarding the mask and bishop attacks. So here I will just really go for the implementation itself. So int target ranks would be equals square divided by 8. Okay, and integer target file that would be equal to square divided by modular of 8, like this. Now we can finally start generating our attacks. So okay, and I just probably I don't need this stuff here for now, and I won't test this separately. So print bitboard. Well, as far as this function of mask rook attacks would return the unsigned 64 unsigned lon U64 data type, which is also known as bitboard. We can print this, and we can actually send this as an argument or a printboard function that actually takes the bitboard or unsigned lon integer as its argument. So we can simply say here like mask rook attacks like this, and the square, let's put the rook on d4, just centralizing first, just to see all the rates available there. Okay, and also obviously I need to compile and run this stuff, and in order to do this I need simply to say like gcc bitboard.c -o bitboard would be the name of the binary executable, and if it compiles I want to run the bitboard executable. Okay, so nothing for now because we're not really affecting our attacks. It just initialized to 0 and nothing is done to this basically. So here let's start from the very beginning. So when it was about the bishops, we needed to give an offset to both target rank and target files because bishop is moving diagonally. But in case of rooks, it's literally enough to just simply give an offset to only ranks or only files respectively, and the only difference would be in calculating the target square. So remember that this expression is used in order to convert files and ranks to the square, assuming the 8-to-8 board. So this 8 stands for the board width basically. Okay, so let's start with rank equals target rank plus 1, so incrementing our target rank, and rank is less equals than 6 in order to avoid masking the board edge the squares on the board edge, just as was shown in Arena GUI, and we want to say rank plus plus here. And now we need to say attacks bitwise ORed with and this expression. So we're shifting the bit, 1 bit unsigned lon to the particular square, and in order to calculate the square, so as far as we don't really have this file being initialized, right, it's just nothing here, so not initialized, then we need to say simply like, but what we have our rank, so we can say rank multiplied by 8 plus, and we're using this target file here, so plus target file, and this should print 1 ray attack already. Okay, we have this, so 2 squares downwards are being attacked. So let me just show you, if we just put this rook on say d7 like this, so now attacks downwards until, but it doesn't go to the board edge, so just as the implementation requires basically. Okay, but let's drop back to d4 actually, and now we need to cover other directions. So let's cover the opposite direction here, and now we need to make sure that the rank is greater or equals than 1 to make sure, again, the same, that we're not masking the board edge square. and as far as the direction is opposite, we need to decrement the rank instead of incrementing it. And okay, the square should be the same. Okay, so we have this rook on d4, and we're masking upwards and downwards. So now let's go to the falls basically. So I can simply say for fall equals target fall +1, and make sure that fall is less equals than 6, so it doesn't go to the board edge, and fall ++. And in this case, attacks are about to be bitwise ordered with 1 unsigned non-bit left shifted with, and now an expression to calculate the square would be the following. So we do have our fall, but we don't have our rank initialized. So that's the reason why we're using this with this target rank. So we can say target rank multiplied by 8 plus fall, like this, and that should print another attack rate. Okay, perfect. And the very last thing left here is actually to print this in the opposite direction. So I can simply say like for f equals target fall -1, and in this case make sure that fall is greater or equals than 1, and decrement the fall, and the tax would be literally the same like previous. One unsigned long left shift with target rank multiplied by 8 and plus fall, like this. Okay, so yeah, it seems so. Okay, now we got all the directions being covered here. So we just let's say put the rook on, let's say a1, then these are the directions. So just like how rook actually attacks, but obviously it's not the way of testing this, and in order to test whether this stuff works correctly or not, we need to look through all the available squares and print the rook mask for every square available. So here I just need to replace this mask bishop with a mask rook, and here we go. Okay, I just want to clear and run again. So just start from the very top here. Okay, so we're starting with a rook occupying a 8 square, and these are the attacks, and then we're moving the rook. Nothing goes to the left because the edge of the board. Now this is how it looks. Now this, okay, perfect. And then go in the next square, a7, and going 3 rays at the moment because this one is the board edge. And now we have already 4 rays. Okay, perfect. So we're just moving the rooks on every single square through the squares. And just like in case of the bishops, with these bitboards, at least in chess program in Wikipedia, they are considered to be the keys that is supposed to be multiplied with, by the so-called magic number in order to obtain the index of attacks for the rooks, bearing in mind the occupancy and some more tricks being involved there. But for now, it's not. It doesn't really matter that much because we're just simply implementing our rook offsets, nothing much but the rook offsets. Okay guys, so it seems like it's working quite pretty nicely, and I guess this is it from my side, at least for this video. So I hope you learned something interesting out of this tutorial regarding how to mask rook squares. And again, like, just to give a credit to Tord Romstad, the author of Stockfish Chess Engine, one more time. So this is his elegant solution of actually generating this, of masking this slider piece attacks. So this is it from my side. Thanks for watching. Until the next time, and take care.